Welcome back to Topic 43 for Algebra 2, Inverse Variation. In Part 2, we're going to define what inverse variation is, as well as apply it to some examples. So first, what is inverse variation? Inverse variation is a function that's represented in the form y equals k divided by x. Or, sometimes you may see it x times y equals k. And that's because if you take the first equation that we wrote down and multiply both sides by x over 1, you'll get the second equation, xy equals k. Now here, x cannot equal 0 and y cannot equal 0. Because if either of them were in the denominator of this fraction, then it would be undefined. K still remains the constant of variation, which is always non-zero. But when we read it, this would read as y varies inversely as x. And it would graph not as a linear function, but as a rational function. Let's get into examples and non-examples. For inverse variation, remember how we have this constant, k. And in the first slide, we saw that we could rewrite the inverse variation form as x times y equals k. In other words, if we multiply our x value by its respective y value, we'll get a value. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. 4 times 3 is 12. 6 times 2 is 12. And 12 times 1, also 12. Notice here how these are all consistent. This is what we want. It's called the constant of variation. This value can't change. However, if we look on the right-hand side and we multiply these values together to see if they give us a constant, 1 times 20 is 20. 2 times 17 is 34. 3 times 14 is 42. 4 times 11 is 44. 5 times 8 is 40. 6 times 5 is 30. So here, these values are not consistent. So this is not an example of inverse variation. Looking at the problem, the variable y varies inversely with x. If y equals 4 and x equals negative 2, what is x when y equals 7? So we can set up the form y equals k divided by x and plug in. So when y is 4, x is negative 2. Now we can solve for k. If we multiply both sides by negative 2, k equals negative 8. So we can rewrite our equation as y equals negative 8 over x. So again, all we did was just plug in negative 8 for k. With the new value, we want to determine what x is when y is 7. So if y is 7 and we know k is negative 8, we want to determine what x is. I can multiply x to both sides, cross multiply here, and get 7x equals negative 8. Divide both sides by 7 in order to get x alone, and we get x equals negative 8 sevenths. Perfect. Moving on to a more traditional word problem. the time it takes to travel a given distance varies inversely as the average rate of travel. So here, my two variables, I have the time it takes as well as the rate of travel. So t equals our constant divided by the rate. In the first example, we have averaging 42 miles per hour. It takes Bryant 5 hours to drive to Boston. If it took him 4 hours and 20 minutes to reach Boston on his last trip, what is his average rate of travel? Plugging in, we know that it takes Bryant 5 hours, and we want to solve for k. This was at a rate of 42 miles per hour. We can multiply and get that k equals 5 times 42, or 210. We can rewrite our equation as t equals 210 divided by r. Now we can plug in. Our time here is 4 hours and 20 minutes. Now notice in our first part of the example, it just took Bryant 5 hours, whereas 4 hours and 20 minutes, we have 2 units we're dealing with here, hours and minutes. So let's make it so it's just 1 unit. We can rewrite 4 hours and 20 minutes as a fraction. This is the same thing as 4 1/3 hours. Set that equal to 210 divided by the rate. Now in this example, I want to make it an improper fraction, so it'll be easier to solve for r. 4 times 3 gets us 12, plus 1 gets us 13/3, equals 210 divided by r. Now we can use the cross product property in order to solve for the rate. 13 times r gets us 13r. Then we have 210 times 3, which gets us 630. Now I can divide both sides by 13. Let's go to Desmos to simplify this. 630 divided by 13 gives us 48.46153846. Let's round to the nearest hundredth here. 48.46 miles per hour. So to summarize, Bryant's average rate of travel was 48.46 miles per hour. Now often, because miles per hour is referenced usually as a whole number, you can also round down to about 48 miles per hour. And that was part 2 of topic 43 for Algebra 2 on inverse variation. Thanks for watching.